My name is Venkata Manoj Pasupuleti, and today I'm going to talk about harnessing microfrontends for building scalable, reliable, and secure application. In today's fast-paced digital environment, building scalable, reliable, and secure platforms for complex web applications is crucial. And as these applications continue to grow in complexity, traditional monolithic architectures often struggle to keep up, leading to slower development cycles, scalability challenges, and a higher risk of system-wide failures. Microfrontends, today's topic, offers a solution to this problem by breaking down these monolithic applications into smaller self-contained units, with each unit having its own independent life cycle. This modular approach not only simplifies the development and maintenance, but also enhances the scalability, enabling teams to work on more autonomously and efficiently. Today, we'll deep dive into these microfrontends, where we'll understand these core principles, exploring their advantages, and discovering how they will empower us to build a scalable, reliable, and maintainable web applications. Next slide. Firstly, let's start with what are the challenges of the existing web applications with monolithic architecture that are out there. If you see on this slide on the right-hand side, you'll see a monolithic architecture-based application where you have the front-end layer, the web application layer, and the integration layer, which is typically your GraphQL layer, and the service layer, typically your Node.js or Java, Spring Boot application, or any Python or Rust-based application that's out there. In a monolithic application, what happens is all these three layers are combined into one particular application, and they're distributed and scaled and deployed across. In this picture, let's try to understand the limitations of this traditional monolithic architecture, particularly as these kind of applications continue to grow in complexity. And the challenges that we highlight below will show why we need to move towards microfrontends, why is it necessary. So the first one is tightly coupled code bases and scaling issues. In monolithic architecture, the front-end, back-end, and the integration layers are often interwoven into one single code base. This tight coupling makes it difficult to scale the individual components. For example, if the backend API layer, for example, here the Node.js or the Spring Boot application, if you start to see more application load towards the bait because both there are more number of requests or there is more complex logic that these servers needs to do, what you typically do is you deploy more instances of this application. But in this case, you can't deploy just the backend API layer independently. You will have to deploy the entire application because there is no other ways. This approach is inefficient, not just inefficient, but it also is risky as it introduces unnecessary complexity and the potential points of failure during deployment. The second issue with this monolithic architecture is the slow development and the deployment cycles. For example, imagine this case that you're onboarding a new team member. For him or her, understanding the monolithic system can be daunting because they need to get a complete grasp of the entire application before they start contributing effectively, which slows down their productivity, also brings down the team's velocity. Additionally, the complex nature of the code base means that changes in one area, for example, in the UI layer, often requires comprehensive testing across the entire application. For instance, let's say you want to deploy a small UI update. You can't do it in isolation. You'll have to test the entire application from front end, the integration layer and the backend layer before you go ahead and deploy. So this delays the time to market for any feature. The third main issue with monolithic architecture is the cascading failures. For example, in a monolithic architecture, a small change or a small bug in one part of the application can cause unexpected issues elsewhere. For example, if there is a minor bug in the authentication module, there is a very good chance it could affect the user dashboard somewhere else. So this leads to cascading failures, and it often gets very difficult to find out where exactly is the root cause for this problem. The lack of modularity increases this wide risk of system outages and makes troubleshooting often very challenging. The next more main issue with monolithic architecture is the lack of flexibility of technology. So what happens with monolithic architecture is you often lock yourself into this specified technologies or framework across the application. And this can be limiting because, for example, let's say for part of your application, you want to use a different technology or a different version of a given library, that gets very difficult. And because you are like tied up to given technology, framework, and version across the app in this architecture. The next one more issue that you tend to see in this architecture is team coordination challenges. So as team continues to grow, coordinating development between different team, like within the team in this monolithic architecture, becomes very difficult. Teams working on different features usually often step on each other's toes, leading to merge conflicts, bottlenecks in CI/CD pipelines, and in the overall a slow progress. This lack of ownership and modularity can hinder a team's autonomy and reduce the developer velocity. So based on these challenges, it's clear that we need a more modular and flexible and scalable approach to build modern web applications. Microfrontends comes to the rescue. Microfrontends address these issues by enabling teams to develop, test, and deploy independent front-end modules, leading to faster delivery, reduced risk, and enhanced scalability. Now to the next slide, the power of microfrontends. So microfrontends are a game changer when it comes to building scalable, reliable, and maintainable web applications. Their effectiveness lies in a core set of principles that define how we approach the modern development. If you see, for example, in the picture over there at the right, the same monolithic application that you've seen in the previous slide can be broken down into three different applications. For example, let's take the example of, let's say, Amazon, which is again uses microfrontends in its application. So there could be an independent app instead of the entire Amazon application being built as one big application and deploying it. What they do is like just the cart experience that you see is a separate team. They might use React on the front end and they might use Java at the back end. Similarly, the main page, the Amazon.com web page that you see, there could be a different team that could be working on it. And similarly, the payment team. Similarly, search is being like, that's another team that's working out of there. Micro frontends, what happens is this gives teams to work on different parts of the application independently and deploy and make changes over there. Micro frontends, what you get independent scalability and deployability. One of the greatest strengths of micro frontends is their, like I was saying, the ability to operate independently, wherein each micro frontend can be developed, test, and deployed separately, allow teams to release new features without impacting others' application. It seems how it feels is it seems like a very well choreographed dance where each team moves in sync with other without stepping on each other's toes, resulting in a faster, smoother, and more frequent deployments across. Secondly, one more thing in micro frontends are smaller code bases for faster development. So the breaking down of this huge monolithic application into smaller manageable pieces, micro frontends reduce the complexity of the overall code base. This approach enables us for faster development cycles as team can focus only on their specific micro frontend without needing to understand or test the overall system for making a deployment. This means that you can ship newer features very fast and improve the significant time to market time. You can significantly improve. The next thing is with the advantage for micro frontends is resilience and fault tolerance. One of the core feature that micro frontends offers is complete decoupling. So basically, by decoupling different parts of the application, micro frontend inherently build this resilience and fault tolerance. If one component fails, let's say your cart fails or your search fails, it doesn't bring down the entire Amazon.com website. Let's say if payment is having some issue, you can still browse for the product, you can still add product to the cart, whereas you might not be able to check out, but all the other functionalities will go through. And this reducing the risk of the overall total system downtime, and it enhances the overall system robustness. Technology agnosticism. Like I was saying previously, with Microfrontend, the individual teams can choose the best tool for their job. Like Amazon homepage might think, oh, there's just too many re-renders and everything that's happening on my web page, let me use React. Whereas probably the payment team might think, hey, okay, for my application, what I'm trying to do, I would rather use Vue.js. So this technology agnostic approach allows teams to leverage their expertise, or even it also depends on the team composition. Let's say most of the team members on the particular project or the team knows Vue.js more than React.js or even AngularJS, then they could go ahead and build that particular application in the technology they choose or they're most comfortable with. There is no tying up of like you have to use only this particular technology, this particular version, etc. Next thing is, finally, it gives you scalability at every level. It's not just at the application, it gives scalability across the entire process. So Microfrontends just does not offer scalability not in terms of technology, but it's also in terms of team structure. For example, as your application team grows, you can scale your teams, each focusing on different microfrontends without risking of creating this monolithic bottleneck. This distributed approach of development allows your organization to grow more organically, accommodating larger teams and building more complex applications without sacrificing the performance or the agility that you get in smaller teams. Next slide. So what do we need to keep in mind when developing this microfrontends? What are the best practices? What are the architecture patterns? And what are the challenges that you usually see or have to keep in mind when building such micro-frontend applications? So the first choice you tend to make is, do you want to split your monolithic application either vertically or horizontally? So what I mean by vertically is, for example, let's say in the example of Amazon itself, let's say breaking it now, like for example, let's say any e-commerce website. So for example, it shows you a list of products that they have. One page like allows you to check out, which contains the cart, and the third pane manages the payment. One way splitting it vertically would mean that the entire homepage will be owned by one team, the entire cart page will be owned by one team, the entire payment team will open. So they'll own both their front end and their back end services. Horizontal splitting would be, for example, would be like a team will own the entire UI, a team will own the entire API. But typically, the vertical splitting is seen more often across the industry, be it, let's say, at IKEA or Spotify, wherein individual teams will maintain both their front-end UI layer and the back-end layer for part of the function. Like Amazon.com, the homepage will be owned both the UI and API by one team. The cart team UI and API will be owned by one team. And the payment UI and API will be owned by one team. So that's like vertical splitting. That's an architecture pattern or how they have chosen it. Similarly, you also have to keep in mind that you need to establish clear communication and contract boundaries. Ensure well-defined APIs for communication between micro-frontends, and this avoids tight coupling between them. This also allows you to iterate independently as long as they adhere to this contracts. So one more challenge that is there in micro-frontend is cost micro-frontends communication and status. So previously, the entire application is one application. Like in monolithic application, the entire application is one. So it's easier for one component to talk to each other, the other, and all that. Now, since with micro-frontends, all of them are separated, are different applications, you need to be careful about or be cognizant of the fact that it's not pretty straightforward how the components can talk to each other. So that's why we need to use well-defined API and use event-driven architectures to manage the interactions between these micro-frontends. I would say probably look up tools like, let's say, event buses, global state managers, or even talk to your backend microservice to help this communication between these micro-frontends. Another challenge or thing to keep in mind is maintain consistency of user experience. So because there are different teams working on different parts of the UI, you also want to make sure that all these experiences that we are building are cohesive and they all feel like they belong to the same web application, the same page. So an idea how we could solve this problem is you need to establish a comprehensive design system and enforce UI UX guidelines across all the micro front-end applications that you're building. Or even shared libraries or components can also help maintain this consistency. So it feels to the user that, oh, okay, although this given web page like Amazon.com is being powered by, let's say, 10 different micro front ends, but it feels like one website to the user. It doesn't feel like, okay, the search doesn't look different, the homepage doesn't look different, the cart page doesn't look different. It all feels like everything together looks like Amazon.com. It does not feel like each of these pages different. Each page is different or being built by different teams. The last one is security concerns. So because now all these applications are being built by different teams and different developers, ensuring consistent security practices across the entire application is important. So we need to develop a unified strategy that includes secure communication, consistent authentication, and authorization practices. And each of these micro frontends should adhere to the same security standards to avoid any vulnerability across the slides. What are these micro frontends? Micro frontends help break down large monolithic web applications into smaller independent units, allowing for modularity and scalability. What are its key benefits? Main benefits are independent scalability. Teams can develop, test, and deploy these micro frontends independently, leading to faster release cycles and better scalability. Faster deployment cycles, because now that you have smaller code bases, results in quicker development and deployment cycles, enabling rapid future updates. Reliability. In one micro frontend, like I was saying, will not affect the entire application, enhancing the overall system reliability and security. Technology agnosticism. Teams can use different technologies for different micro frontends, promoting flexibility and innovation, and teams can work in technologies that they're most comfortable in and they're strong at. So what are the best practices and challenges that you need to keep in mind while designing this application? Are you need to choose the right architecture pattern. Like I was saying, you either choose the vertical splits or the horizontal, horizontal splits, so how you want to break down your overall monolithic application into parts. So you also need to establish this clear communication, where to define these API contracts and maintain the shared libraries for all the applications to use. Ensure consistency. That's a huge thing, because for the customer or the user, whoever is coming to our webpage, we need to make sure that they don't get a feel that they call for on a given page, it looks like 4 different web applications are stitched together on one page and they feel or look or work differently. So that should not happen. Few real world examples of like really huge companies that have embraced this methodology and are using as of today. For example, few of them could be Spotify, Amazon, IKEA. There are a few examples that are out there that have been using and have been spearheading this technology. So what are my final thoughts? So micro frontends offer a powerful approach to building scalable, maintainable web applications, but require careful planning and execution. Embrace the modularity, leverage the best practices, and address the challenges proactively to maximize the benefits of micro frontends. Thank you all. Thank you so much for taking time to join me today to go over this micro frontend based architecture based presentation. Thank you all.